Yeah. So in this session, we'll be talking about string encodings. So when I say string encodings, in Python, how do we use string, and in what way the internally the string is stored? All those things will be discussed. So when we say string, normally it is made up of characters. Conventionally, the characters were made up of ASCII codes, ASCII things, or in ASCII codes, and then extended ASCII was there. So when you say ASCII code, only 128 characters can be represented. Only the English language was able to be represented. But when it comes to extended ASCII, German, French, and all those characters were included. The language characters were included. Still, extended ASCII supported only up to 256 characters. That's it. But beyond that, if you had to support Chinese characters or Korean or any other Indian languages, Indian language characters, then we need extended encoding. Okay, that is where we need unicode. Okay, the concept of unicode. So Python makes use of unicode characters. So when you say unicode characters, the any characters of the language, any language in the world can be represented. And here every character is represented as a code point. Okay, here we don't call it as an ASCII value, but we call it as code point. For example, the English character, alphabet character A, small a, has a code point of 97. Okay, and beyond that, if you go beyond 256 characters, okay, then we'll go for everything has got 228, or sorry, above 226. Some other value will be that's called code point. Actually, I'll be just demonstrating those things. So Unicode is a standard designed to represent every character from every language. So it can handle any text of the world's writing systems. Be it Tamil, okay, be it Telugu, or Malayalam, Kannada, Hindi, whatever language you take, okay, then any character can be represented. Okay, so that's called Unicode characters. And now you see in Unicode there are different variations. Are there UTF 32? UTF is nothing, basically it's an abbreviation for Unicode text, okay, transformation. Okay, Unicode text transformation. Okay, now Unicode 32, Unicode 16, Unicode 8. Okay, the all are different varieties. So in Unicode, in UTF 32, no, every character takes up 32 bits. That means 4 bytes. Okay, so the advantage is, okay, you can easily, when you do linear search, you can immediately go to the nth word, okay, nth 4 byte word by just indexing. Okay, but when you take it takes every character, it occupies 32 bits actually. That's called 4 bytes. Okay, to improve over that, we have UTF 16. In UTF 16, every character takes up to, okay, that's called variable length encoding. Okay, some characters they take up to 16 bytes actually, 16 bits actually, 2 bytes or 16 bits. Fine. And UTF-8 is still a variable length encoding where, okay, some characters will occupy only 8 bits. That means 1 byte. And beyond that, some characters will occupy 2 bytes. Some characters will occupy 3 bytes. Okay, for example, if you take in alphabets of English language, they'll occupy only 1 byte. But if you take some character like an omelette, okay, which will occupy 2 bytes. But if you take a Chinese character, will occupy 3 bytes. So all those things we'll be discussing. Okay, and these are all the different Unicode transformation formats. Fine. Now let us see strings, how they can be represented in our Python, and then we'll see some examples. Okay, so let me get into my Conda Navigator followed by Jupyter Notebook. Look at this. Now this is my Jupyter Notebook editor. I'll just say uh, text. Text is equal to, I'll just say welcome. So now if you look at this now, if you look at the length of this, print len of text. Len of text. So it takes 7 bytes actually. It takes 7 bytes. Okay. See, 1, 2, 3, 4, 5, 6, 7. 7 bytes it takes. Indexing will be 0 to 6. That's a different issue. But now what happens? I want to encode using different UTF formats, the same text. So I'll say format one f1 is equal to text dot encode using UTF, okay, 32. Then let me just type print length of f1. Look at this. Look at this. So when I put UTF 32, okay, the length becomes the length. See, when I encode it using UTF 32 format, basically it's a byte encoding. See, here it is basically it's a code point. See, every character has got welcome. W has got a code point. E has got a code point. Okay, if you want to, you can just see the code point of that particular character. Look at this. Just say text of 0. Okay, so I'll just say print, okay, text of 0. I'll just show you the code point by a function called ORD function. Look at this. You see, 119 is the code point of W. Suppose if you want to go for E, okay, let me just check it. Okay, text of 1. Okay, let us see the code point of ORD is a function which gives you code point of the particular character. See, 1 means indexing 1. See, basically string starts with index 0, 1, 2, 3, 4, 5, 6, up to 6 it goes. Now text of 1 means E. E is code point I want. So I'll just comment all these two. See, you just block and control forward slash will comment everything. Okay, first way of commenting. I'll just control enter. See, 101. The 101 is for E. Okay, see, small a is 97, E is 101. That's it. It is called code point actually. Code point. Now, when I just comment it out, okay, even I comment, okay, let it be that. Now you see F1. F1 is the, I am converting, okay, encoding into UTF-32 format. So the result will be a set of bytes actually, set of bytes. Now I'll just show you the length actually. Look at this. Length of F1. You can see here. It takes, 32 actually, 32 bits actually. Okay, fine. So how it is exactly 32? Okay, let us see that. See 1, 2, 3, 4, 5, 6, 7. 7 fours are, okay, 28 plus 4 byte for UTF-32. UTF-32. Okay. See here, as I told you, in UTF-32, every character will be encoded using 32 bits. That means 4 bytes. 4 bytes. Every character will be encoded using 32 bits or 4 bytes. So you can see there are 7 characters. So 7 into 4. Okay, I'll just write it down here. 7 into 4 will be equal to 28 plus 4 bytes for UTF-32 format. So it will be 32 bytes actually. It will be 32 bytes actually. It's not bit actually, it's 32 bytes. Okay, because every character occupies 4 bytes. Keep this in mind. Okay. Suppose if I say 16. Now look at difference. See the difference. 16 means, so there are 7 characters. 7 into 2, because 16 means, there are 2 bytes. Okay, UTF 16 means 2 bytes. So every character occupies 2 bytes. Okay, so there are 7 characters. 7 into 2, 14 plus 2 bytes for, okay, UTF 16. So it will be 16. Answer will be 16. Look at this. Look at this. 16. Okay, it takes 16 bytes to store this, okay, value actually. So it's nothing but 7 into 2, because why 2? Because 16 bits means 2 bytes. Okay, plus is equal to 14 plus UTF-8 format requires extra 2 bytes, so it will be 16. Okay, that's the difference. Suppose if I say UTF-8 means every character will occupy exactly, okay, 1 byte. And now it should be there will be no extra character for UTF-8. It will be only 7 bytes, I think. Let's see that. Yeah, 7. Okay, so easy. When I represent using UTF-8, okay, the number of bytes which are required, it's called byte encoding. Actually, it's called byte encoding. Okay, the number of bytes which we require is, see, it depends on the number of characters which we store. See, every character is basically has a code point. But when you encode it using UTF-8, every code point is converted into a byte format. Byte. Okay, fine. So how many bytes they occupy? Okay, so when you say UTF-8, now every character, for example, W will occupy 1 byte, E will occupy 1 byte. So like that, 7 bytes will be occupied. Okay, so this is called encoding. Okay, basically it's called encoding of in different formats: UTF-32, UTF-16, UTF-8, everything. Okay, and the length will be, see, totally the length of this will be 7 bytes actually. So 7 Unicode points, 7 bytes, because it's UTF-8 it is. If you, for same 7 characters, 7 code points, when you go for UTF-16, it will be 7 characters into 2, 14 plus 2. 2 for extra UTF-16 takes 2 bytes to represent that it's a UTF-8 16 encoding. Okay, it's not UTF-8 encoding, it's UTF-16 encoding. Okay, so based on the encoding scheme, the number of bytes differ. Okay, fine. Now I can have I can just display the code point of with the other see some extra characters code points. I'll display and show you. Just comment it out. Now let me take some characters. I think I'll take from internet some Chinese character. I'll just go here. Let me take this character. Control C. I'll just come back to my document. Just say Control V. Copied, I think. Copy. Control C. Come back to my this. Control V. Some space. I'll delete those things. I have only one character. So let me just find out the length first. How many characters are there? Okay, look at this. Only one character is there, but it's a Chinese character. You can say I just took from Wikipedia. Look at this. I took from Wikipedia site Chinese characters. Okay, so I just copied one character. So there is only one code point. There is only one code point. Okay, definitely there is only one code point. Let us see what is the code point of the Chinese character. That's the next step. I'll just say ORD of ORD of text of 0, because there is only one character. You have to give text of 0. Yeah, look at this. Chinese character is 20,063 as code point. See, alphabet, A, small a, 97 is a code point. But this particular Chinese character, okay, comes at a code point called 20,063. Now you can see the Unicode for the representation. See, you can represent any language in the under the sun, any language characters under the sun. So this is Chinese actually. Now I think we have seen what is the code point of this particular Chinese character. Even I don't know what is that character, but this is a code point of this particular character. Now let us encode it using okay, UTF-8, and let me print the length actually. Just delete this. Okay, it takes 3. Okay, look at this. It takes 3 bytes. See, you just watch the difference. Normal English characters, welcome, when I put welcome. If I put welcome, every character occupied only 1 byte in UTF-8. In UTF-8. But the same Chinese character in UTF-8, it takes 3 bytes. See the difference. Okay, fine. Suppose if I make it to 16, let us see how many bytes it occupies. It takes 4 bytes. It takes 4 bytes. One byte extra actually. Suppose if we make it 32, okay, it takes 8 bytes. It takes 8 bytes. UTF same, okay, Chinese character. UTF-8 it takes 3 bytes. UTF-16 it's 4, and UTF-32 it is 8 bytes. 8 bytes. Okay, so this is the way we encode the normal any character under the sun using different schemes actually, using different schemes. Fine. Okay, so I think this is what I wanted to say with respect to this particular slide. Now you can see here the strings can be represented within single quotes or double quotes. So what I can do, I can just go here, the string. So that's, these are all things I want to discuss with respect to encoding and things. Now let us move on to escape and go to B, so that it comes to next thing. I'll just say text is equal to I'll take a welcome text. Welcome. So if I had to represent, if I had to display, so now if I say print text, I'll get text as it is. Now if I want to put a single quotation within this, then what happens? The moment you put single quotation, what happens? It takes as the delimiter. Delimiter means end single quotation. So if you want the single quotation to be part of that welcome string, then you should escape, put a slash. That's it. The moment you put slash now, then this single quotation becomes a string. That means part of that welcome. Now let us see the output. Look at this. WL single quotation come. So this is called escape sequence. That's called escape sequence. Okay, fine. So you can escape. So sometimes you have to escape some characters. Okay, so that that character will be displayed. Instead of escaping this way, what I can do, I can put a double quotation. Within double quotation, I can put a single quotation. Look at this. This will also work. Welcome. Okay. So if you want to, the easy way is if you want to put a double quotation inside single quotation. Okay. So suppose you want double quotation printed, put everything within single quotation. Or if you want single quotation to be part of your string, put everything inside double quotation. That's it. That's the easiest way. Okay. Fine. So apart from this, you can have string which goes through multiple lines. Now suppose in this case, I cannot go for multiple lines. I try to do this way now. I try to display things. Let us see what is output. Look at this. Gives me error because the moment the new line is entered, okay, it treats, okay, it thinks, okay, the string has not terminated properly. So to avoid that, what you are supposed to do, you put three single quotations. Okay, that's it. Now wherever you end three single quotations, till that place the text will be. Look at this. Now it becomes multi-line text. Look at this. So you see, this is the starting delimiter, three single quotation, and this is closing three single quotation. So until the closing single quotation, whatever you give now will be part of the string. Look at this. Just this control enter. Look at this. Look at, see the output. Okay. So these are you give, okay, multi-line, okay, strings, multi-line strings. Basically, it's called multi-line string. Yes, multi-line string will be used, okay, at various places. Okay, and then if you had to talk about the subscripts. So when it says subscript now, so let me just escape and delete. Then I can just give B. You can just see here text equal to, just say welcome. Welcome. So when you say subscript now, I can just say text of 0 W. Okay, then I can say text of -1. So that will be last character. Look at this E. If I say -2 from last but one, look at this M. Suppose if I say just 1, it will be second E, second letter E. Okay, this is called subscript. Okay. So using subscript and other things, lot of things we'll be looking at we'll be dealing in the next demonstration. Okay, thank you.